All right, let's solve the above question. All right, so for us to solve this question, we know that this is a trapezoidal load, of which we have just done the derivation for all the equations. But this, we are still going to perform the same analysis here, while in our next video, we are going to be using the formulas to solve. All right, so now for us to do this, we are going to replace what we have here with our reaction at A. All right, so here we are going to have reaction at B. All right, so now we are going to start with the summation of forces in the y direction to be equals to what? 0. That is, here our upward force will be positive while our downward force will be negative. So we are going to say r subscript A plus r subscript B will be equals to, all right, so here we know when we have a trapezoidal load, we have 2 in 1 load, that is uniform distributed load and a what? And a uniform varying load. So if you join this line like this, all right, so if we join this, we are going to have our uniform varying load. All right, so that's it. Now for us to convert this uniform varying load to a point load, we know the load that is the uniform varying load, uniform distributed load is nothing but what? 3 kilonewton per meter. So we are going to multiply this 3 by what? By 8. So we are going to have 3 multiplied by 8 plus, so for this uniform varying load, from this point to this point is 6. For the length of this, from this point to this point, so we are going to subtract 6 from 3, we are going to have 3 kilonewton per meter. So now for us to convert this to a what? A point load, we are going to say 3 multiplied by 8 divided by 2, that is area of a what? A triangle. So we are going to have half multiplied by the base, which is 8, then multiplied by what? By 3. So this will be equals to r subscript A plus r subscript B will be equals to 3 times 8 is 24, plus if you this here 1, this here is 4. 4 times 3 is what? 12. All right, so it means that r subscript A plus r subscript B will be equals to 36. So this is equation what? 1. All right, so the next thing we are going to do is we are going to take our moment about what? About B. So we take our moment, the summation of moment about B will be equals to what? 0. All right, so now it means that this is going to be RA multiplied by what? 8. So we are going to have R subscript A multiplied by 8 will be equals to, because our upward force is positive while downward force is what? Negative. So it's going to be equals to, now when we convert this uniform varying load to a point load, it's nothing but what? 24. And it's going to act at what? At half of the what? The length. So it's going to be 24 multiplied by what? The, we said moment is what? Force times perpendicular distance, right? So we have a point load which is what? 24 acting at the center. So we are taking our moment about B. So it's going to act at what? 8 over 2 to the right, 8 over 2 to the left. And 8 over 2 is what? 4. So that is 4 plus, and that of the uniform varying load is what? Is 12. So we're going to have 12 multiplied by, so this one is going to add at what? 8 over 3 away from what? Our right angle, that is this point. All right, so 8 over 3. So it's going to be multiplied by 8 all over what? 3. So this is going to be equals to 8 r subscript A. R subscript A will be equals to 24 times 4. It's going to give us 96 plus this 3 here 1, 3 here is 4. 4 times 8 is 24. So 8 RA will be equals to 96 plus 24 is 128. So if we divide both sides by 8, so RA is going to be equals to what? So it's going to be 16. 128 divided by 8 is 16. All right. So now for us to get our RB now, so we have our, from our equation 1, we know that RA plus RB is equals to what? Is equals to 36. So our RB will be equals to 36 minus RA, which is what? 16. So RB will be equals to what? 20. So this is going to be in kilonewton. Alright, so our ROA is 16 kilonewton and our ROB is what? 16 kilonewton. So now that we have the reaction at A and the reaction at B, so now we can go for our shear force equation. Shear force equation. Alright, so for us to do our shear force equation, we are going to denote that with S subscript F subscript E, which is going to be equals to, alright, our shear force equation is going to be what? ROA multiplied by what? That is, we are going to section this beam. Alright, so let's just take the section so you can understand this perfectly well. So let's section it here. Alright, so now the distance from this point to this point is going to be what? S. Alright, so why here we are going to have it as W subscript S. Alright, so now for us to calculate what our shear force is, our shear force is going to be ROA, which is the upward force, which is going to be positive, minus the downward force. Alright, so but this, our downward force here is going to be the area of the trapezium here. So you know, if you are looking at this shape now, this shape only, forget about this one that we shape, is still what? A trapezium. So it's going to be ROA minus, and then you know the formula for a trapezium is what? Half into sum of the opposite sides. Alright, so if we stand here, this place is 3, while this whole place is what? WS. So we are going to say 3 plus W subscript what? S. Alright, multiplied by what? Height. So the height of this trapezium is what? S. So it's going to be S. Alright, so but we don't know what our WS is, right? Alright, so how do we get that? We are going to be considering this triangle, similar triangle. We have a bigger triangle here, and from this point, like, we have another triangle. Alright, and this place is going to be WS minus what? Minus 3, because from this point to this point is 3, while the whole length here is what? WS. So it means that here we are going to have here to be WS minus 3. Alright, so from a similar triangle, we are going to have this to be what? WS minus 3 all over S. So WS minus 3 all over S to be equals to, now here the length here is going to be what? 3 all over what? All over the total length, which is 8. So we are going to have 3 all over what? 8. Alright, so if we make WS the subject, WS will be equals to 3S all over 8 plus what? Plus 3. Alright, so we can substitute what we have here in this our equation. So it shows that the shear force equation will be equals to ROA minus half into 3 plus, so we are going to replace this WS with what we have here. That is 3 plus 3S all over 8. Then you close the bracket. Then multiply by what? By S. Alright. So that is what we are going to have. Alright. So we can replace our ROA now. Our ROA is what? 16. So it shows that here we are going to have the shear force equation to be equals to 16 minus half into 3 plus 3 is 6. And then plus 3S all over what? 8 multiplied by what? S. Alright, so if we open that bracket, we are going to have 16 half times S multiplied by S is going to give us what? Minus 3S. Then half times what we have multiplied by S is going to give us minus 3S squared all over what? 16. Alright, so this will be our shear force equation. It's going to be 16 minus 3S minus 3S squared all over what? 16. Alright, so now we are going to be using this equation to get the shear force at point A, the shear force at point B, and where we are going to have our shear force to be equals to 0, because we know that where our shear force is equals to 0 is where we are going to have what? Maximum bending moment. All right. So now we are going to start. When S, you know, at point A here, our S is equals to 0. While at point B, our S is equals to what? 8, the whole length. So at S equals to 0, our shear force at A will be equals to 16 minus 3 into 0 minus 3 into 0 square all over what? 16. So 0 multiplied by this is 0. 0 multiplied by everything that we have here is 0. So we only have what? 16. So the shear force at A will be equals to what? 16. Alright. So at S equals to 8, we are going to have the shear force at B, which is going to be equals to what? It's going to be equals to 16 minus 3 into 8 minus 3 into 3 square all over what? 16. Alright. So if you look, so now this, we are going to have this 16 minus 3 into 8 minus 3 into 8 square all over 16. We are going to have this to be equals to what? 0. If you press that correctly. So everything here is going to be equals to what? 0. So it shows that the shear force at A is 16 and the shear force at B is what? 0. Alright. Now, we said we need to know where our shear force is equals to what? 0. So when our shear force equation is equals to 0, the value of S that we are going to have there is going to be the value that we are going to have what? Our maximum what? Bending moment. So when we equate this to be equals to 0 now, so when shear force is equals to 0, we are going to have 16 minus 3s minus 3s squared all over what? All over 16 to be equals to what? 0. Alright. So we are going to multiply through by 16. So this will become a quadratic equation. So we are going to clean this part. Then we'll continue. Right, so we are going to multiply both sides by 16. So if we do that, 16 multiplied by 16, that is 256. So we are going to have 256. Then 3 times 16. So we are going to have minus 48s. Then if we multiply that by 16, we are going to have minus 3s squared. Everything will be equals to 0. So if we rearrange this, if this one go to that side, we are going to have 3s squared, then plus what? 48s. Then if we take this to the other side, we are going to have minus 256 equals to what? 0. Alright. So, and you can just apply your quadratic formula here. That is, you want person. Alright. So from quadratic formula, we have our S to be equals to minus B plus or minus square root of B squared minus 4AC all over what? All over 2A. Alright. So and we know that our A is the coefficient of S squared, our B is the coefficient of S, our C is the number here. So we are going to have S to be equals to minus 48 plus or minus square root of B, that is 48 square minus 4A is 3 multiplied by C. C is minus 256 all over what? All over 2 multiplied by 3. Alright. So here we are going to have S to be equals to minus 48 plus or minus the square root of 48 square. And 48 square is what? Minus 3 multiplied by 3, 4 multiplied by 3 multiplied by minus 256. If you do this, you are going to have what? 73.3. Alright. All over 6. So this is going to be equals to, so if you take the square root of everything that you have here, you are going to have 73.3. So here we don't have any square root here. So it's going to be 73.3. Alright, so now the value of our S now is going to be minus 48 plus 73.3 all over 6, or minus 48 minus 73.3 all over 6. Alright, if you look at this value here, it's going to be a negative answer. it's going to give us a negative answer. And if you look at our beam, we don't have any negative value there, so we are going to neglect this. All right, so let's focus on this. So minus 48 plus 73.3 divided by 6, we are going to have 4.22. So S is equals to 4.22. All right, so this is the value at which this is the value that our shear force is going to be equals to what? 0. And here is where we are going to have our maximum bending moment. All right, so that's it. So now let's go for our bending moment equation. All right, so now for our bending moment equation, you just need to go for our shear force equation. So our maximum bending moment will be our bending moment equation will be equals to here that we have 16 is going to be 16 multiplied by what? By S. Because this is our 16 here. If we multiply that by S, we are going to have the moment at that point. So it's going to be 16S, then minus 3S here. 3S is the uniform distributed load here that is converted to a what? A point load. So, and for us to get the moment here, we are going to multiply this by X over 2. You understand? So we are going to have 3S multiplied by X over 2, then minus Y 3S squared over 16 is for our uniformly varying load. So for that is the force. If we multiply it by X over 3 now, we are going to have the moment. So we are going to have 3S squared all over 16 multiplied by what? X over what? Over 3. All right. So now if you do this, we are going to have our bending moment to be what? 16S minus 3S squared all over what? 2. Then here we are going to have minus 3S cubed all over. Or you can just see that this 3 will go with this 3. So we can just have this to be S cubed. S cubed all over what? All over 16. All right, so this is our bending moment equation. All right, so now let's get the bending moment at point A, the bending moment at point B, and the maximum bending moment. All right, so the bending moment at point A is going to be at S equals to 0, because at this point A, our S is equals to 0. So the maximum bending bending moment at point A is going to be equals to 16 into 0, then minus 3 into 0 squared all over 2 minus 0 cubed all over what? 16. So all the value here is going to give us what? It's going to give us 0. All right. So now at S equals to 8. At S equals to 8 now. At S equals to 8, we're going to have our our bending moment at B to be equals to, so we're going to have 16 into 8, 16 into 8, then minus 3 into 8 squared all over 2, then minus 8 to the power of 3 all over 16. So if we do this, we are going to have our bend moment at B to be equals to 0. So we are going to have this to be equals to 0. All right. All right. So our bending moment at point B is 0. So there is a little error here. When you press your calculator, you are going to get negative 20. Yes, you are going to get negative 20. We are going to have negative 20 here. All right. And don't forget your unit. It's going to be in what? Kilonewton. Kilonewton. All right. So, and this one is going to be in a meter. All right. So this one is going to be kilonewton meter. Right. This is going to be, so since it is there, let's just put it kilonewton meter. Kilonewton meter. All right. So that's it. Now, don't forget, we already have our S to be equals to 4.22. So if we substitute 4.22 for our bending moment equation, for this equation, so we are going to have our what? Our maximum bending moment. All right, so I'm going to clean this side, and I will be cleaning everything that we have here so that we can draw our shear force and the bending moment diagram. Wait. So now we are going to substitute 4.22 in our maximum in our bending moment equation, which is this. So we are therefore going to have maximum bending moment. All right, so this will be equals to 16 into 4.22, then minus 3 into 4.22 all over what? All over 2 minus 4.22 all cubed all over what? 16. All right. So by the time you press this, you are going to have 36.11. All right. So 36.11 is our maximum bending moment. So this is going to be kilonewton meter. All right. So now we are going to, now that we have the value of our shear force at A, at B, and the maximum, our bending moment at A and B, and the maximum bending moment, we can therefore draw the shear force and the bending moment diagram. All right. So for us to do that, we are going to draw this line downward. All right. So here we are going to have this. All right. Therefore, draw our reference line. Let's have our reference line here. Right. All right. So now, here is going to be 0. Here is going to be 0. All right. So let's take, since we don't have any negative value for our bending moment, so let's take this down. All right. So now, for our shear force, now let's start with shear force. So the shear force at A is 16. All right. So this is A, is 16. So let's take this place to be our 16. So let's take this place to be 16. This point here is 16. All right. And the shear force at B is minus 20. All right. So this minus 20. Let's take this point here as minus 20. All right. So now, and we know that the value of S, where we have our shear force to be equals to 0, it was 4.22. So 4.22 is going to be at somewhere around here, since the O length is 8. So our 4.22 is going to be somewhere around here. Somewhere around here, right? So somewhere around there. All right. So we can therefore join this curve now to our what? We can therefore join these three curves together. All right. So we are going to draw, since we know that this is a maximum, a uniform distributed load and a uniform varying load. That is a trapezoidal load. So everything we are going to have here is going to be a what? A curve. Is that clear? So now it's going to be like this. Let's just try it out. I'm going to have this. It's like this. So something like this. I don't know. This is not good. I can pause it. So this is how it's going to be. This is how it's going to be. So this is 16. This is negative 20. And from this point to this point is 4.22. Exactly. All right. So now, for us to draw our maximum, our bending moment diagram, let's clean this line. Let's take it down a little bit. Let's take this down a little bit. All right. So we know that the bending moment at point A is 0. So this is 0. And the bending moment at point B is also what? 0. Right? All right. So now if we trace this point down, because we know that it is from this point that our shear force is equals to what? 0. So our shear force is equals to 0 at the point. So we trace it down. So at the point that our shear force is equals to 0 is the point that we have what? Our maximum bending moment, which is what? 36.11. So we can just take this point to be 36.11. So we are going to draw a parabolic curve to join the 3 curve. All right. So let's just take it like this. All right. So we can shade it now. All right. So this is going to be positive, while this one is going to be negative. All right. So here we have 36.11 here, kilonewton meter. All right. So everything here is positive. All right. So this is how to go about this question. And stay tuned for more. Thanks.